One urban farm in Baltimore, Maryland produced over 14,000 pounds of produce last year. That is food that is feeding a community. And it's just one of the 33 urban farms and over 200 community gardens working in Baltimore. And each one of those farms and gardens is dependent upon a reliable water source. But finding water that's safe, affordable, and accessible isn't always easy. Just last fall, Baltimore had 38 consecutive days without rain. And during that time, there were restrictions on water usage. But the need for water never went away. That's where we think rainwater harvesting could come in. Because while there was a drought in the fall, the summer brought in over 9 inches of rain in Baltimore. If we could have captured that rain, it could have been a tremendous supplemental source of irrigation water for urban farms and gardens, especially as climate continues to change. But there are issues with this water. Rainwater is collected off of a roof, and anything on the roof, like bird poop, could get into the water, and we don't really know what kind of bacteria could be in the rainwater if it's collected on an urban farm. That's where my research comes in. I'm interested in understanding the microbial quality of harvested rainwater and determining if there are effective treatment options for reducing contamination. To do this, I have 3 goals. First, I want to know if there's bacteria in the water that would indicate that feces had gotten into it. To do this, I'll look for E. coli. Second, I want to know if there are human pathogens in the water, specifically Listeria monocytogenes and Salmonella. And third, I want to know if either a filter or a chemical sanitizer could be used to reduce contamination. I worked with a great team of farmers and researchers to collect rainwater at a research farm. We set some of that rainwater aside as untreated, then the rest of it we treated by either running it through a filter with sand and iron shavings in it, or dosing it with peracetic acid. That's the chemical sanitizer. Then we took each of the different water types and we used it to irrigate beds of brassica salad mix. So what did we find? Well, let's start with the E. coli. We found E. coli at an average concentration that was higher than some irrigation water standards. But both of our treatments were able to reduce the concentration of E. coli. What about our pathogens? Well, we found Listeria monocytogenes in about 15% of our untreated harvested rainwater samples, and less than 10% of our filtered water samples, and never in our sanitized rainwater samples. Luckily, we did not find Salmonella, and when we looked at our produce, no matter what type of irrigation water we used, we did not find any of our target bacteria. So we think harvested rainwater could be a great supplemental source of irrigation water, but we recommend treating it first.